the smart fence attached to the clincher, this allows you to have what's called the cabinet making system. This allows you to use your JoinTech equipment for more than just standard joint making operations. Now, in all woodworking projects, it requires that you have good, square, clean edge stock for all of your joints. Now, normally you would need a jointer to do that, but with the smart fence and your clincher, you can set your unit up as a jointer machine. Now, how that is performed is this. First of all, we'll put a large diameter, half-inch or larger, half-inch shank, carbide-tipped router bit in your router. Then, loosen the nuts on the back of the fence on both the in-feed and out-feed faces, and push the faces forward, just like that. You will notice that on the ends of both fence faces, there are little hex head thumb bolts on here. And if you look through the little holes in the fence, you'll see numbers. And those numbers equate in 64ths of an inch to how far you can make the fence facing protrude out when the bolts are tightened. Now, we'll want the outfeed fence to be at its furthest position, so we put it on 7 and then shove it back in like that. And then don't tighten the nuts, but just move them in fairly close to the back of the fence. To give us some offset like you would have on a joiner, we'll start with the infeed on 6, and that will give us a 1/64th of an inch variation between this fence and the outfeed fence. And then we'll shove it back in, and again move the bolts in, the nuts in, so they almost touch the back of the fence, but not quite. Now then, we'll slide the fence over the router bit and move the fence facings up until they come close but still have a good margin of safety, 1/8 of an inch or so, away from the cutter edge of the router bit. And the same thing with the outfeed fence. And again, leave yourself at least 1/8 of an inch away from the router bit. Now, we want to make the cutter edge of the router bit even with the outfeed fence face. So what we'll do is take a straight edge and rotate the cutter so that top dead center is facing out, and then put it in the 45-degree detent position and move the fence forward until the fence just touches your straight edge. Now, this may take 1 or 2 trial cuts to get it to where you get a nice straight cut. Now, lock the cam handle in position and you're set up for joining. To give yourself a little extra safety, take your piece of stock, sit it in here, and you can take the feather board, slide it over the top, let it drop down over on your piece of wood, lock it in place, lock that in place. And that'll help keep your stock down against the table and also help to keep your fingers away from the router bit. We've got the dust collector hooked up to the back of the smart fence on the dust chute because the majority of the router bit is in the interior of the fence. Look at your grain on your wood. And you'll notice on a lot of pieces of wood, the grain has a tendency to run downhill. That is the direction that you want to feed the piece of wood into the rotating cutter so that it cleanly scoops the wood out. that will give you a nice, smooth, straight edge. Now, if the opposite happens, the bit is sticking too far out, what would happen at the end of the cut is as we exited the router bit, the board would, or the cutter would snipe. In other words, this would drop in against the face of the fence and leave a dig or a divot right here on the end. In that case, you would want to micro adjust the fence forward a little bit until you got rid of that particular cut. Now, we have it set at 1/64. If you want to take more off, you can back this up and take as much as a 1/16 off at a pass, depending upon the hardness of the stock. Now, there are other steps in preparing your stock than just edge jointing. The next step is generally ripping the stock to the width that you want, and that's normally done on the table saw. Now, as you've seen earlier, we have the 26-inch table saw system set up on our saw. Now, previously, I took the unit and slid it all the way forward and paralleled it against the face of the saw blade and then locked it down at its furthest extension to the table saw top. Now, what we want to do is cut this piece of wood 2 inches wide. So all we need to do is slide the clincher forward to 2 inches on the scale and drop the cam in place. Now, this is where the table saw system gives you a very, very accurate fence over other types of fences available, because you still have available to you the use of the micrometer thumb wheel to get those very precise cuts that you might want to have for certain joinery operations. You will appreciate this fence over other types of fences if you ever go to cut large sheet materials, because when this fence is locked down, it has very, very little, if any, side movement whatsoever in it. So you're going to have a very sturdy, rigid fence for your table saw. The third step in dimensioning stock is to cut it to the final length. If you refer to the JoinTech project book, you'll find the plans to build this nice cutoff sled. Now, this utilizes the 27-inch standard fence that is available for the JoinTech clincher system. What we'll do is simply make a beginning cut on one end of the stock. And then we've got the stop block set and dimensioned to the side of the saw blade, and one of the tapes up here. And I've got that set at 8 inches, so I can now take that squared in and run it against the stop block and then cut my piece to length. Now you can see how the JoinTech cabinet making system can be a true advantage to just about any shop. In keeping with the cabinet making aspect of the clincher system, what we're going to do is begin making a couple of varieties of raised panel door frames. The first one we're going to do utilizes the grooving cutter that we used earlier when we cut the notch in the fence facing. What we want to do at this point is move the clincher forward until the face of the fence is just even with the ball bearing on the grooving cutter. Now we'll move the cam lock into the 45-degree detent position and then use the micro adjustment to adjust the fence front to back or forwards and backwards until the ruler just kisses that bearing. Then lock the clincher down solid. Now you'll notice that I have attached the featherboard accessory to the table, and I've adjusted that so that when I feed my piece of stock in, it will just flex a little bit and hold the piece in snugly against the fence. I'm also going to insert the vertical featherboards so that they fit right over top the router bit, and it sort of keeps your hand back and away just a little bit from the router bit. That's a little tight. And then it also helps to keep the piece of stock pressed securely down against the table while we're making the cut through the router bit. Now, just like with jointing, look at the grain of the stock and run the piece of wood so that the router bit is curving in and the stock is running down in this manner. The grain pattern is running down and away from the router bit. This gives you an ideal example of one of the uses of these inserts in the fence where they benefit your routing, because if this router bit were totally exposed out and around the cutter edge, what would generally happen is you'd have a lot of splintering of this stock. Since the router bit is totally surrounded by that insert, it helps to prevent the edges of the stock from chipping away and giving you unsightly chip-out marks along the edge of your material. To create the tenon on the ends of our pieces of stock, we're going to use a straight router bit that is set just under the thickness of one of the edges and just less than how long the tenon has to be for the joint. And then we're going to creep up with the router bit and move the fence backwards, exposing a little bit more of the router bit each cut until we get the right fit that we want. Now, I've also referred to the JoinTech project manual and made the cope cutting fence that I've attached to the front of the vertical push fixture with a clamp, and that simply lets you take these pieces of stock and hold it like you would with a miter gauge, and hold this in place as you make your cuts. And it keeps your stock square so you don't have to use a miter gauge, and it also provides you with a backup to help reduce splintering as you cut across the grain. Our first cut looks like it's just right at the finished depth for the tenon. All we need to do now is move the fence back a little bit more to make the total length of the tenon for our joint. And that gives you the first side of your mortise and tenon, or of your tenon, to fit your mortise or fit this slot. Now, I discovered that in the process of creating this, that one side is slightly thicker than the other. So to create the other side, it'll mean that I will have to adjust the router bit up just a little bit to compensate for the thickness. With the router bit height readjusted to match as closely as possible the flip side of our piece of stock, we'll now take and machine away in 2 bites, again, this thickness here. Once again, we move it to the final depth and make our second pass. And that will give you a completed mortise and tenon joint for your rail and stile construction for a cabinet door. This is the project that we're going to start covering the construction of throughout the remainder of the video. You'll notice that the top is essentially a version of a raised panel door. It has rails and stiles, and then it has a panel in the center. And we'll cover some of the joints, and what we're going to cover now is how I constructed this particular rail and stile using router bits. Now, the router bits that we're going to use here is a 2-piece rail and stile set. The one piece that I already have mounted in here, the one set, is what is used for making the cope cut, which is the cut on the end, similar to what we did with the router earlier when we created the tenon. The second set makes the cuts, the vertical cuts, down the length of all 4 pieces, rails and stiles alike, and is the mirror image mating cut that you have of this router bit here. Now, I have replaced the insert in the smart fence with one that has been cut and machined to match this particular bit set. And what we'll do is, again, slide the fence over and adjust the face of the fence until the straight edge just touches the fence facing and the bearing both, and that will give us the maximum depth of cut on our stock. Again, we'll use the vertical push fixture with our little jig attachment to help hold the stock square to the face of the smart fence. And that gives us the beginning of our joint on the ends of both of the rails. I've changed the router bits to the cutter that will make the groove cut down the length of the stock. And I made a test cut just to be sure that I had the right height and I would get the flush surface that I want. If you don't get that flush surface, you're going to have to adjust the router bit up and down just a little bit till you get that, because it's almost impossible to sand enough material away to make it flat once you've run the pieces. Now, once you've made your adjustment, you want to make sure, once again, that you've got the router fence set flush with the bearing, and that way you get the maximum depth of cut of the groove, and lock it in place. On hard material, you may actually have to make two cuts. Make a shallow cut and then a deep cut. This material here is soft enough that I can run this in one pass and it will not really cause us any problem whatsoever. Again, we're going to have the feather boards that will push the stock in against the fence, and the feather boards that will double as a guard over the cutter and also keep the stock pressed down securely against the table. And just make this in one long, smooth cut. When you're completed, you should be able to slide the corner joint together and have a nice fit, just like what you see right there. Now, there's a couple of different ways that you can make your panel itself using the JoinTech system. The first method we're going to use is to use wing style, or what are called horizontal cutters. Now, this one that I have in here is about 3.5 inches in diameter. This is a little bit smaller version of the same type of bit with a different shape. This has like a 15-degree angled design to it, and this is what's called an ogee. Both of these router bits require a high horsepower, 2.5 on up, variable speed motor in order to be able to swing these and get the proper cut that you want on your stock. If you try to run these in a fixed speed router, 20,000 RPM on up, you'll burn the stock badly, and it can be rather scary at that speed. So generally with these bits, you run it on a variable speed router at a low RPM, down around about 10,000 RPM, or whatever the lowest speed is on the variable speed router that you have. Now again, I have installed a insert into the fence that's been machined to match the profile of this router bit. And that again will support the stock around the router bit, and it'll also help to alleviate some of the chipping that you would get normally on this type of a bit. Now this is what's called a limited cut or anti-kickback style bit, so it is a little safer than some bits are, but still this insert gives you that much more cushion. Now what we want to do is once again slide the fence out until we just touch the face of the face of the bit, the face of the fence, and the bit, and then adjust the fence forward or backward until we get the exact cut that we want. Now I have the bit set down somewhat low. I make these cuts in several passes. Don't try to hog the material all off in one bite. Even though this is a high horsepower router, it still does not deal well with taking heavy cuts in this stock. And again, we will use the feather boards partly as a guard and partly to help keep that stock pushed down over top the router bit as we make the cut. After our first series of cuts, you can probably see we've got the beginning of the 15-degree bevel, and then it drops down to a 1/4 inch flat shoulder, and that flat shoulder is what will ultimately fit inside the groove on the inside of your rails and stiles for the frame. So what we want to do is continue increasing the depth of cut of the bit and continue making cuts until we get this to be just a slip fit into the rail pieces. Now remember, you probably may have noticed I started going across the grain first, then go with the grain. That way if you get any splintering on the edge, you'll get rid of it as you go down the length. Now the last cut that I made was just a very light pass all the way around to try and sneak up and make sure that I had the right thickness on the edge and had the cleanest possible surface all the way around to reduce the amount of sanding that will be required on these faces. And we can take our panel, and it should fit into the door frame just like that. Our second panel that we're going to make is going to be made with a vertical panel raiser. Now there's a distinct advantage to this type of bit over the wing style or horizontal cutter, and that is that this bit requires a less or a lower horsepower router and can spin at a higher RPM and give you the same cut. You don't have to have a 3 horsepower router with variable speed. You can run this at 20+ thousand RPM on a regular 1.5-horse router and get a good job. Now you'll notice that we have a couple of other accessories added to the table. One is the fence raiser attached to the top of the smart fence. With the vertical panel raiser, the stock is run, as the name indicates, vertically, just like this. The purpose of the fence raiser becomes quite obvious, and that is to keep the stock from tipping over the height of the fence. The other piece we're using, again, is the horizontal featherboard set. But you'll notice that I have modified it slightly by shimming it up 1.5 inches. The reason for this is so that the featherboards are pushing against the stock above the height of the router bit. if you have the feather boards pushing down against the table, as you remove the stock, it would cause the panel to kick in and take a big bite or a snipe out of the face of your panel and ruin it. And the only real shortcoming to this type of bit at all is the fact that you have to take the stock off in smaller bites due to the small diameter of the bit. You can't take an 1/8 or 3/16 off like you can with the horizontal cutters. You really should only take 1/16 of an inch at a time. So we will move the clincher in so that we've got it set to where 1/16 of an inch of the router bit protrudes beyond the face of the fence. And then we can run our piece of stock right down the length of the fence. Now the only problem that we have here is that we still could possibly get a little bit of tipping one way or the other if we have a very long and narrow panel. So once again, go to your JoinTech project book and make this little jig that's outlined, and that will slide right over top of the fence razor. It comes down the back side of the panel and helps you to hold this square as you run the piece of stock over the router bit. Again, start cutting across the grain and then go with the grain. Now, just as with the horizontal cutter, you can see that we have the beginnings of our bevel, and then we also have the little lip that will go into the rails and stiles. So what we'll have to do now is just continue making 1/16 of an inch cuts progressively until we get a lip on here sufficiently narrow enough to slide comfortably into the frame. Now, as you move the fence out, exposing more and more of the cutter, you'll also need to correspondingly move the feather boards forward as well. We have the fit down to where it will almost slide in the groove, but not quite yet. So what I've done is I've adjusted, or I'm going to adjust the fence backwards just a little bit more. I'm going to adjust it backwards about 1/64 of an inch, which is half a turn, and that should give us the fit that we want for our final cut. And once again, that gives us the beginning of our joint. And we should be able to take and slide the other pieces in place. and have a completed raised panel door that in our case we can use for the lid of our box.